right, we are working on the geometry final review worksheet. It's the one without the multiple choice. We're on problem number 22. I see the picture and I instantly recognize the chord. I think it's on, there it is, number 14 on the circle notes page. This is the chord. It's AB equals CD. And that means that we're going to get the answer by saying 8 times x is equal to 6 times 4. So the piece of this chord times the remaining piece, 8 times x is equal to this piece times this piece. So that's 8x is equal to 24. Divide both sides by 8, and x is equal to 3. Don't you hope they're all that easy on the final exam? All right, so it tells us that quadrilateral ABCD is a parallelogram. They're telling us BD, that's this one right here, is 5. DF is 4, and CF is 2. So when you look at this equation, or when you look at this picture, you need to see that we have a pair of vertical angles here and here. And then we also have a pair of alternate interior angles here and here. Because remember, this is a parallelogram. So if it's a parallelogram, that means that this DC right here is parallel to AB, and it also means that AD is parallel to CB. Well, if these two lines are parallels, then this one right here is a transversal, and that means that alternate interior angles are congruent. So why am I so worried about those angles? Well, because with two pairs of angles that are congruent, I've just proven that a triangle ABE is similar to FDE. I'm going to sneeze. Excuse me. So with similar triangles, we can get, we know we have proportional sides. We have congruent angles and we have proportional sides. So that means that I'm going to be able to write I like this color better. I'm going to be able to write a proportion to find out the missing side. Now, notice I took the fact that this was 5 right here, and since I needed this piece for this triangle and this piece for this triangle, I said, okay, well, I don't know. DE was one of the things that I needed to find. I don't know how big DE is, so since that's an unknown, I'm going to call it X. And then this one right here, I don't know. I'm going to have to find that one too, and I don't know what that is, but instead of putting another variable there, I said, well, if this is X and the whole thing is 5, then this piece right here is 5 minus X. So the fewer variables we can have, the better off we'll be. So we need corresponding parts so that we can get a scale factor, and we can see that DF, so DF is a part of the smaller triangle, this one right here, is going to correspond to AB. So DF, which is 4, corresponds to AB, which is 6. So I can say 4 over 6 reduces down to the 2's divide out. So 2/3 is my scale factor. Okay, so since 2/3 is my scale factor, this is going to be one of the ratios that I can use to solve the proportion, to solve the missing side. So 2/3 is the scale factor, and now I need to find out side DE. Okay, well, side DE This one right here is going to correspond to this one right here. DE corresponds to BE, so DE corresponds to BE. So I put the smaller side on top. I put the 4 on top, so I'm going to put the X on top. And then I'm going to put the 5 minus X on bottom. Now I have a proportion, and all I have to do is cross multiply. So 2 times 5 minus X is equal to 3X. Be sure you distribute. That's 10 minus 2X is equal to 3X. Add 2X to both sides, and 10 is equal to 5X. Divide both sides by 5, and X is equal to 2. So that means that DE is 2, and BE is 5 minus 2, which is 3. All right, so that's number 22 and number 23. I've been checking them, so let's go over here. 22 and 23. X is 3 for number 22, and DE is 2 and BE is 3, which I believe is exactly what I got. Okay, so number 24. The radius of the circle below is 20, so I marked the radius. I drew a radius. I could have drawn it anywhere, but I drew it to where it's most helpful, and I marked it as 20. The length of AB is 24, and that was marked. And then because of what it asked, how far is AB, the distance from a line to a point is always the perpendicular distance. So I know that this is part of a radius, so I can draw a radius and perpendicular to that chord, and when I do that, I create obviously a right angle, and it divides that chord into 2 equal pieces. So that's why I did a 12 right here and a 12 right here. And now all I got to do to find this chord, this looks like a Pythagorean triple. I don't know why this is automatically coming up purple. I like this one so much better. Pythagorean triple, this 12 right here is 3 times 4, and this is 5 times 4. So this looks like this one over here is probably going to be 16, because that's 4 times 4, because that's a 3, 4, 5 Pythagorean triple, and you multiply them all by 4, and you get 12, 16, 20. So 12, 16, 20. Of course, you don't have to recognize that it's a Pythagorean triple. You could just say 12 squared plus x, well, we'll say b. 12 squared plus b squared equals 20 squared, and that would be b squared is equal to 20 squared minus 12 squared, and that's going to be b is equal to 16. So the answer is 16. How far is AB from the center of the circle? 16 units. Okay, looks like we have a geometric mean situation over here based on the drawing. They gave me this is 4 and this is 12. I did use all these variables because I have 2 different proportions that I can work with. I've got the leg is the geometric mean to the whole hypotenuse and the part adjacent to the leg that we're using. And then I've got the altitude is the geometric mean to the 2 parts of the hypotenuse. So we're talking about this part and this part. So these are the 2 parts. So just to make sure, this is a leg, this is a leg, this is the altitude, this is a part, this is a part, and then this right here is the whole hypotenuse. So that's the part that I'm talking about right here. So they asked me to find CD, so I called that X. They asked me to find AD, so I called that Y. And they asked me to find AC, so I called that Z. You didn't have to name them. You could have used CD, AD, and AC in the formula, but I'm old school and I like using my variables x, y, and z. So let's see. We start off having the piece of information that we know first is a leg. So since we know a leg, then I'm going to be using this one. So the leg is the geometric mean. That's what I put right here, right here. It says leg goes on bottom, leg goes on top. So the leg is a geometric mean to the whole hypotenuse. So that is 4 plus y. And then the part that's adjacent to the leg that we're doing. So that's 4. So now I have to cross multiply. And I can distribute, or I can just divide both sides by 4. I'm going to divide both sides by 4. You know why? Because people always mess up with the distribution. So 144 divided by 4 is 36. Subtract 4 from both sides, and y is 32. So AD right here is 32. So this measurement right here is 32. That means that the whole hypotenuse now is 36, because 32 plus 4 is 36. Now, when I go to find the other leg, and it doesn't matter, or I could find the altitude, I'm going to go ahead and do the other leg. I'm going to do the leg is the geometric mean. Okay, so the z goes here and here to the whole hypotenuse, and the segment that's adjacent to the leg that we're talking about. So we're going to use this part this time. So cross multiply, 32 times 36 is equal to z squared. And take the square root of both sides. And I'm going to do 32 times 36. And then I'm going to take the square root of it. Uh-oh, I hit the wrong button. Square root, answer. And still haven't gotten it yet because I hit the wrong button. Why is that not giving me? I know it's, well, okay, let's do it like this. So this is a perfect square. This is 6 times 6, and this is 32 is 2 times 2 times 2 times 2, 1, 2, 3, 4 times 2. So I know a 2 is going to come out, another 2 is going to come out, and a 6 is going to come out. So this becomes, I'm doing this by hand because my calculator was not cooperating. So 2 times 2 is 4. 4 times 6 is 24 square roots of 2. So I'm going to make sure that that's right, because that does seem big. But 24 square roots of 2 is the same decimal that I got when I took the square root of this number right here. So this is the exact value. I hope that didn't confuse you terribly, because all I did was factor each one of these because I knew I was about to take the square root of it. I looked for pairs. Pairs are perfect squares, so they come on the outside of the square root. This number right here stayed on the inside. If you need help doing this, I can send you a video that's on simply simplifying radicals. But some of you may have a calculator that'll do this for you. I don't know why mine wasn't doing it, because it usually does it beautifully. I'm going to try it one more time. The square root of 1152. The square root of 1152. Nope, it's changing it to a decimal every time. Don't know why. Maybe there's too many, maybe it's, I don't know why. But anyway, that is the exact value right there. The decimal value is about 33.9. But I think that's video is going to be long enough. So I'm going to stop after we check and show you that my answers are right, 24 and 25. So there's 24 square roots of 2. There's 32. CD, they said, was 8 square roots of 2. I don't remember getting... Oh, did I? Maybe I didn't finish it. I bet that's what happened. I bet I didn't finish it. Yeah, I got sidetracked. So X, let me finish that right here. X is the altitude. So this will be the proportion that we use. So the altitude is the geometric mean to the two pieces. So the two pieces of the hypotenuse. So that means 32 times 4 is equal to x squared. And again, I'm going to factor this one the same way. 4 is a perfect square. But to be in, this is 2 times 2 times 2 times 2 times 2. 32 is 5 2s. So 1, 2, 3, 4, 5, 6, 7. That's equal to x squared. So we take the square root of both sides, and this pair will come out, this pair will come out, and this pair will come out. So that's 2 times 2 times 2. That's 8. And this 2 has to stay inside. Okay? Again, I brought a pair of 2's out. I brought another pair of 2's out. I brought a third pair of 2's out, and that 2 had to stay inside. And 2 times 2 times 2 is 8. So there's the altitude, 8 square roots of 2, 24 square roots of 2 is this leg, and 32 was the piece of the hypotenuse. All right, my next video will start with problem number 26.